The moon is not what we thought it was. It hides something inside. November the 20th, 1969. The Apollo 12 crew has left the lunar surface. Their empty ascent stage is now falling back toward the moon at nearly 6,000 kilometers per hour. It hits hard in the ocean of storms. And the seismometer the crew left behind starts recording something no geologist on Earth expected to see. The moon vibrates, then keeps vibrating. For nearly a full hour, 55 minutes of continuous ringing after a single small impact. Solid rock does not do that. Solid rock absorbs the energy and stops within minutes. In Houston, the seismologists look at the trace and cannot explain it. So they write it up quietly, publish the raw data, and let the sentence that follows sit almost unnoticed in a Nature paper. The moon rang like a bell. That is the phrase the record used, and nobody in the public ever heard it out loud. Take a second before we go further. Wherever you are watching from tonight, whatever time it is where you sit, look up if you can. That familiar face has been above every human being who ever lived. Every tide, every calendar, every hunting season, every religion, every love song. All of it built around an object we assume we understand. We do not. The seismic signature was only the first anomaly. Its density is wrong for a body of its size, sitting at 3.34 grams per cubic centimeter when Earth clocks in at 5.51, and even smaller, Mercury reaches 5.43. The moon is the outlier in its own neighborhood, and no origin story cleanly explains why. Then there is the mass distribution problem. GRAIL, the twin satellite mission NASA flew in 2012 specifically to map the lunar interior, returned a gravity field so uneven that engineers had to invent new phrases to describe it. Underdense regions, porosity in the crust, cavities and voids at scales we can measure directly. Read those words twice. That is not the language of a solid rock. That is the language of something structurally incomplete. Here is the thesis, stated plainly, because this story is not going to hide it. The object we call the moon does not behave the way the textbook says it does. Every serious mission we have flown to it since Apollo has quietly deepened that problem rather than solving it. And the deeper you look, the more you realize the tides, the seasonal axis, the very stability of the planet you live on, all depend on something we still cannot fully explain. You have been told the moon is a dead rock. The seismic data says otherwise, and what comes next is worse. Here is the version you were taught. Roughly 4.5 billion years ago, when the solar system was still young and chaotic, a Mars-sized body called Theia struck the early Earth at an angle. The collision vaporized most of Theia and a large chunk of Earth's outer layers. That debris, thrown into orbit, cooled and eventually gathered itself into the moon. It is a clean story. It is the story on every classroom poster, in every science documentary opening, in every children's book about space. It closes with a comforting sentence. That is how the moon was born. It is also the story that isotope chemistry has been quietly dismantling for over 20 years. Before we go into that, tell me something honestly. Wherever you are watching from, were you ever taught the Theia hypothesis in school? Did anyone ever mention that scientists were unsure? Or did it arrive to you the way it arrived to most people, as settled fact? Hold that answer while we look at the data. Here is what should not be possible if Theia were a separate body. When you measure the oxygen isotope ratios in Apollo lunar samples and compare them to Earth's mantle, they match. Not approximately, precisely. Vichert and colleagues confirmed this in 2001. Then, Zhang and colleagues did the same test with titanium-50 in 2012. Same result. Identical. Then Teboul and colleagues looked at tungsten-182 in 2015 and found another anomaly the simple Theia model could not clean up. Now think about what that means. Every planetary body in our solar system carries a unique isotopic fingerprint. Mars has its own, Vesta has its own. Every meteorite class has its own. Two bodies forming in different places do not end up with matching signatures. It does not happen. And yet the Moon and the Earth have signatures so identical that statisticians have quietly stopped calling it a coincidence. The scientific literature is full of workarounds. Maybe Theia formed in Earth's orbit and shared the exact same starting material. Maybe the collision was so violent that the two bodies fully mixed before separating. Maybe there was a synestia, a temporary donut of vaporized rock that homogenized everything. Each patch keeps the impact story alive, but each patch also admits the original version does not work. That is the crack. The Theia story is not a fact. It is a preferred narrative propped up by increasingly complicated repairs. And if the origin story is wrong, then the age, the interior structure, the composition, everything downstream of the impact model is standing on softer ground than anyone has told you. To understand why the Moon is strange, you have to know what a normal moon should look like from the inside. Take a body of comparable size. Mercury, for example, or one of the larger icy moons like Ganymede. They all follow the same general structure. A dense metallic core at the center, a hot, partially molten mantle around it, a relatively thin crust on the outside. The proportions vary, but the pattern holds. The heavier material sinks, the lighter material rises, and the whole body settles into layers like a slow-cooking soup that eventually finds its equilibrium. That is the model. Now look at the Moon. Its iron core is tiny, only about 350 kilometers in radius, compared to Earth's core at over 3,400. That is not a small difference. That is a core so small it should not be able to power the kind of magnetic field the Apollo rocks show the Moon once had. And yet, the magnetic imprint in ancient lunar samples is unmistakable. Something drove a dynamo in that little core, and nobody has fully explained how. The crust is the next problem. GRAIL mapped it in 2012. The result was thinner than every previous model had predicted. 30 to 40 kilometers on average, in some places less than that. On Earth, the continental crust averages around 35 kilometers on land, but our planet is roughly 4 times larger by radius. A body the size of the Moon should either have a thicker crust or a hotter interior to justify a thinner one. It has neither. Imagine cracking a hard-boiled egg and finding most of the yolk missing. That is roughly what GRAIL found. A shell that should not stand up structurally, wrapped around a center that should not be that quiet. Between the crust and the core sits a partial melt zone, a layer of rock that Apollo seismic data suggests is still hot enough to deform, sitting at around 1,000 kilometers depth. That layer is what should have supplied the material for a bigger core, or a thicker crust, or a more active geological history. Instead, it just sits there, half-cooked, unresolved. Read the GRAIL press release carefully, and one phrase appears more than once: porosity in the crust. The lead scientists chose that word deliberately. It means the crust has empty spaces, cavities, places where the mass is not accounted for. The physics is asking a question the answer sheet skips. Porous is the polite word. Next, we look at what actually fills, or does not fill, those spaces. In 2017, the Japanese space agency JAXA published something that should have made front pages around the world. Their Kaguya orbiter, using a radar sounder, had detected a massive underground void beneath a region called the Marius Hills. Not a small tunnel, not a modest cave, a structure roughly 50 kilometers long and around 100 meters wide, sitting empty beneath the lunar surface. NASA's Lunar Reconnaissance Orbiter confirmed the findings shortly after. Then, in 2022, a team from the University of Trento reanalyzed radar data from the Mare Tranquillitatis pit and found evidence of a second confirmed cavity beneath it, opening into what looks like an intact tube. Stop and let those numbers settle. 50 kilometers is roughly the length of Manhattan, and then some. 100 meters wide is wider than most subway tunnels. This is not a metaphor. This is a hollow structure inside the moon, mapped from orbit, with instruments we trust. For comparison, Earth's longest known lava tube, Kazumura Cave in Hawaii, runs about 65 kilometers, but only reaches around 20 meters wide at its largest points. The Marius Hills structure is comparable in length and roughly 5 times wider. That is not a small scaling difference. That is a different category of feature. Now go back to what the GRAIL press release said. Porosity in the crust. Underdense regions. Those phrases were carefully written to describe a mass distribution that only makes sense if the interior is full of empty spaces the size of these confirmed voids, and probably many more we have not yet detected. The gravity data implies more. The direct radar imaging confirms at least 2. The math does not close cleanly if these are the only ones. Here is where the story stops being abstract. NASA's Artemis program, the current effort to return humans to the moon, is actively planning to use these lava tubes as radiation shelters. That is not a fringe idea. That is baseline mission architecture. The agency believes the tubes exist, believes they are structurally intact enough to walk into, and believes crews will need to descend into them because the surface is not safe for extended exposure. Read that again. The people planning the return trip are counting on cavities inside a body they still call solid. If the moon is this hollow at scales we can measure directly, what is happening at the scales we cannot? The gravity anomalies suggest the answer is not comforting. And that is only the geology. Now scale that forward. What happens when we ask this body to hold something heavier than a flag? Here is the assumption baked into almost every conversation about returning to the moon. We did it once, in 1969, with slide rules and vacuum tubes. Therefore, doing it again, with 50 years of additional technology, should be easier. Building on it should be a natural next step. Living there should just be the same thing, extended. That is the intuition, and it is wrong at every scale. Look at what Apollo actually did. Each mission delivered roughly 15 metric tons of hardware to the lunar surface for a stay measured in hours, or at most, 3 days. The crews were there long enough to plant a flag, collect rocks, and leave. Nothing they built had to survive a second sunrise. Nothing had to hold pressure through a 14 Earth day night. Nothing had to feed anyone through a resupply gap. Now look at the current architecture. NASA's Artemis base camp concept targets over 60 metric tons of surface infrastructure, habitats, power systems, rovers, life support. China's ILRS program is aiming for a permanent presence by around 2035. Both plans assume crews will stay for weeks initially, then months, then continuously. That is not a modest increase over Apollo. That is a categorical jump. Landing once is not the same as living there. Living for days is not the same as living for months.
And living for months on a stable crust is not the same as living for months on a crust with confirmed subsurface voids, regular shallow moonquakes, and mass distribution problems we still cannot fully map. The Apollo passive seismic array, running from 1969 through 1977, recorded 28 shallow moonquakes strong enough to matter. Some reached magnitude 5.5. On Earth, a magnitude 5.5 earthquake damages buildings
even when those buildings were designed by 200 years of accumulated seismic engineering. On the Moon, every structure a crew builds will be first-generation hardware on a crust the engineers themselves describe as porous, sitting above a partial melt zone whose behavior we cannot predict with confidence. This is the scaling rupture that public messaging never quite states. A base is not a bigger tent. A permanent presence is not a longer visit. Every increase in mass, in duration, in crew size, in dependence, multiplies the risk in ways that do not track linearly. And here is the part that should bother you. The first serious lunar base will be built on a body whose interior is less mapped than the ocean floor of Earth. We know more about the trenches beneath the Pacific than we do about what sits under the Artemis landing zones. And that is just the ground. Now look up. Not at the surface, at what is coming down. On Earth, you live inside two invisible protections you almost never think about. The atmosphere absorbs the smaller solar radiation. The magnetosphere, generated by Earth's spinning iron core, deflects the larger charged particles from the Sun and the deeper radiation from the galaxy. Together, they cut the radiation dose reaching your skin to a level your cells evolved to handle. Step off Earth and both shields disappear. The Moon has no atmosphere worth mentioning. It has no functional magnetosphere. According to NASA's Human Research Program, a crew on the lunar surface receives between 200 and 1,000 times the radiation dose of someone standing at sea level on Earth, depending on solar activity. That is not a temporary spike. That is baseline. Every second, every day, for the entire stay. Try to feel that, not read it. Feel it. Radiation as invisible damage, accumulating in every cell of your body, every heartbeat, without pause. You cannot see it, you cannot smell it, you cannot cough it out. You just keep collecting it. Then there is the dust. Apollo astronauts came home with a symptom the doctors did not expect. Harrison Schmitt, the geologist on Apollo 17, called it lunar hay fever. His eyes burned, his throat closed, his lungs rebelled. The dust that had come in on his suit had gotten into the cabin, and his body reacted to it like an allergen. But it was worse than an allergen. Lunar regolith is not weathered dirt. It has never been rounded by wind or water. Every particle is jagged, glassy, and often smaller than a human red blood cell. Electrostatically charged from constant solar exposure, it clings to everything. It gets everywhere, and once inhaled, it does not clear. Microscopic glass shards in lungs that cannot cough them out. Think about what that means over months. Then there is gravity. The Moon holds you at roughly 1/6 of Earth's pull. That is not zero, but it is not enough. Extrapolating from ISS data, where astronauts lose about 1 to 1.5% of bone mass per month in zero gravity, long-duration lunar crews will face significant skeletal loss. Your skeleton dissolving quietly while you sleep, and no amount of exercise fully stopping it. Add the temperature swings. Positive 127 degrees in the sunlight, negative 173 in the dark. 14 Earth days of each. The ground, the sky, the dust, and the body itself. All of it is working against the mission. Now count the money.
The Moon is 384,000 kilometers away. That distance is the number every child memorizes. It is also the number that quietly makes almost every ambitious plan for sustained lunar presence financially impossible. NASA's Office of Inspector General published a report in 2021 that cumulative Artemis program costs would reach roughly $93 billion through 2025. That is not the cost to build a city. That is the cost to land people again. The Space Launch System, the rocket at the heart of Artemis, costs approximately $4.1 billion per launch. Every launch. Not the first one. Every one. Compare that to Apollo. Adjusted for inflation, the full Apollo program cost around $260 billion in current dollars. It was sustained by Cold War political will, national identity, and a specific geopolitical panic that will never repeat in the same form. When that political oxygen ran out in the early 1970s, the program ended almost overnight. 12 men walked on the moon, then no one did for over 50 years. The reason was never technological. It was that the money stopped. Now look at the International Space Station. Roughly $150 billion over its lifetime, continuously resupplied from Earth. Every gram of food, every filter, every replacement part launched from a planet 90 minutes below. And the ISS is inside the magnetosphere. It is in low Earth orbit. Assistance, if something goes wrong, is hours away, not days. The Moon breaks that model. Communication delay is only about 1.3 seconds one way. That sounds trivial. It is not. In an emergency, a 1.3-second delay means every decision made from Earth arrives already old. Ground control cannot react in real time to a suit tear, a fire, a hull breach. The crew is on its own for the moments that matter most. And the water. The current mission architecture depends heavily on ice at the lunar South Pole. It exists, but it is patchy, unevenly distributed, and sits inside permanently shadowed craters where temperatures reach negative 250 degrees Celsius. Extracting it requires infrastructure that has never been built at scale in that environment. Every Antarctic base on Earth requires uninterrupted logistics to survive. Miss one supply run and the base is in trouble. Miss two and it is in crisis. On the Moon, a missed launch does not mean inconvenience. It means the biology from the last chapter starts winning. Sustainable presence. That is the phrase agencies keep using. Why does the public still hear it without flinching? Because the story has been softened. Here is the part that needs to be said carefully, because it is easy to misunderstand. NASA is not lying to you. The engineers are not incompetent. The mission is not fake. This is not that kind of story. But agencies are phrasing, and the phrasing is engineered for continued funding, not for public sobriety. There is a difference between deception and selection. Every serious institution learns to speak in the register that keeps its budget alive. NASA learned that lesson painfully in the 1970s. It has never forgotten. Read the language patterns. Returning to the Moon to stay. Sustainable exploration. A permanent human presence. These phrases are not neutral descriptions of a mission plan. They are calibrated to sound like commitments. They imply that the hard problems are already solved, or will be by the time the crews arrive. They imply that the destination is a foregone conclusion, and only the timing is under discussion. Now compare that language to what the Government Accountability Office has been publishing. The GAO reports on Artemis readiness from 2023 and 2024 use different words. Schedule risk, cost growth, immature technologies, persistent gaps in critical systems. Those are not the phrases in the press releases. Those are the phrases in the technical audits that Congress reads and the public rarely does. Look at the timeline itself. When Artemis was formally announced, the first crewed lunar landing was scheduled for 2024. That slipped to 2025. Then 2026, then 2027. Each slip was announced calmly, framed as prudent caution, absorbed by news cycles that moved on within a week. The pattern is the story. A program repeatedly promising a date it cannot keep is not primarily an engineering problem. It is a communication problem that has become a habit. The gap between the public tone and the technical reality is not conspiracy. It is institutional survival.
Every honest scientist inside NASA knows the risks. Every experienced engineer knows the constraints. But the language that reaches the public has been filtered through public affairs offices, congressional testimony, and 30 years of learned caution about what happens when you tell the country the hard part is hard. The consequence is quiet but heavy. The public is emotionally unprepared for the first serious lunar accident. When it comes, and something at this scale will eventually go wrong, the shock will not be proportional to the risk. It will be proportional to the gap between what people were told and what was true. That is what softened messaging costs. And here is the harder question. If this is the price of returning to the moon, what does it mean for what comes next? Every serious plan to send humans to Mars starts with the moon, not as inspiration, as dress rehearsal. Every architecture document, every mission profile, every white paper on interplanetary settlement treats lunar operations as the proving ground where the hard problems are supposed to be solved first. Life support, radiation shielding, in situ resource use, long-duration crew health. If it does not work on the moon 3 days from home, it cannot work on Mars 9 months from home. So look at the moon honestly, and then look at Mars. The Mars transit alone is roughly 6 to 9 months of continuous exposure to galactic cosmic radiation, well outside Earth's magnetosphere. According to NASA's own dose modeling, a crewed round-trip Mars mission would deliver a radiation load approaching the agency's career limits for astronauts before the crew even lands. Not during the surface stay, before it. And once on Mars, the crew stays for over a year, waiting for the planetary alignment that lets them come home. Closed-loop life support, the kind that would let humans live independently of Earth for years, has not yet been demonstrated for years-long operation. The best current system we have is on the International Space Station, which recovers roughly 90% of its water. That sounds impressive until you realize the remaining 10%, and every food item, every filter, every replacement pump is launched from Earth on a rigid resupply cadence. That is the ceiling of our current biological independence from this planet. 90% water recovery over 90 minutes below, resupplied constantly. Now scale that to a moon that we cannot yet occupy for months without the same crutch. Then scale it again to a Mars mission that has to survive years without any resupply at all. Here is the reframe. The moon is not hiding something inside its crust. The moon is revealing something about us. It is the honest mirror. It shows us the gap between our ambition and our biology. It shows us that a species which has never lived off Earth for longer than an ISS rotation and always inside the magnetosphere is not yet the multiplanetary species we like to describe ourselves as. Every previous age of human exploration succeeded because the environment eventually cooperated. Polynesian navigators found islands. Age of sail crews found continents. Polar expeditions found ice that supported life at its edges.
Space does not cooperate. It only tolerates, briefly and reluctantly. The moon was never the mission, it was the test. And the test result is not pointing where the story pointed. So what does the final verdict look like when you strip away the press releases, the launch live streams, and the language of destiny? Here is the verdict, laid out in the order the evidence gave it to us. The moon rings for 55 minutes after a small impact, and no one has fully explained why. Its density is wrong for its size, marking it as the outlier of its own neighborhood. Its isotopes match Earth's too precisely to have formed as a separate body, and every attempted fix to the Theia hypothesis is another admission that the simple story does not work. Its interior is porous at scales we can measure directly, with confirmed lava tubes wider than subway tunnels, and probably porous at scales we cannot yet measure at all. It kills bodies slowly,
through radiation that never stops, dust that never clears, gravity that never rebuilds bone at the rate life on Earth expects. It costs more than the public messaging admits, sustained by political will that history shows can evaporate in a single election cycle. And every extension of its story, from base to colony to Mars gateway, requires solving problems that the last 50 years of spaceflight have proven are harder, not easier than they looked. None of that is speculation. All of it sits in the published record. Now strip away the last comfortable illusion, the one that says we have been there, so we understand it. Apollo returned 382 kilograms of lunar rock across 6 landing sites. Less than half a metric ton from a body whose surface area is larger than Africa. We have not explored the moon. We have sampled a beach and called it an ocean. Go back to 1969. The seismologists in Houston are staring at the trace of a moon that will not stop ringing. They do not know what to say. They write it up carefully, publish the data, and move on. Now stand in 2026, 57 years later. New missions on the pad, new landers already launched, new architecture on the whiteboard. And still, when the seismic data is honest, we do not know what to say. The moon is not hiding something inside it. The moon is the thing that is hiding, behind familiarity, behind flags, behind photographs so numerous we stopped looking at them. The strangest object in Earth's sky is also the one we have mistaken for the most ordinary. There is narrow hope in that. Artemis, JAXA, ISRO, Chandrayaan, CNSA. Missions are, right now, generating the data that will either close these gaps or widen them. The next decade of lunar science is where the real answer lives. But the answer will not be the comfortable one. You were told the moon is a dead rock. The seismic data says otherwise. And now, so do you.